Okie dokie.
All
Good
right.
morning, Davis. How you doing?
Good morning. We're back.
We're back after a week in Austin, Texas, which was pretty exciting.
Yeah. No, I had a snowy welcome, so I wasn't in Kansas or wasn't in Austin anymore. So that's pretty clear from the current climate here.
Good one. Yeah.
Yep.
No, we had a big U.S. event for Edge AI Foundation in Austin last week. 3 full days of talks and demos and workshops and beer and barbecue and all that good stuff. So had my fill.
Yep.
I'm good with that. Next week is Embedded World.
I need to upload files. Yeah, the saga continues. I mean, it's a Edge AI start to the new year. I mean, I think I need like a downlink or an upload of all the firsthand experience, conversations, presentations to really digest it all. It's been whirlwind.
Yeah, Embedded World next week. I was on a call this morning. I'm hosting a few panels there. Apparently, they're expecting 190,000 people in Nuremberg. So,
wow,
that's kind of insane. So, so we're going to be there with a booth. People should stop by. Hall 4, 602 is our booth. But we're also going to be sponsoring an event with IoT Stars on the 11th, March 11th. If you're in Nuremberg, come by or get some tickets. And it's gonna be a big party. IoT Stars, big community. So do that and visit our booth, visit the NXP booth. I'm sure you'll have some gargantuan pavilion there with state-of-the-art demos and all that good stuff. So it's going to be another intense week of embedded Edge AI stuff.
Yep.
The other thing I wanted to do another PSA.
There'll be a lot of great demos there.
PSA on some. You can see my gear that I'm wearing. Oops, like say this side. Yeah. My hoodie. So we have now hoodies. You can see the back. So to support our scholarship fund, if you want to go to our store. So we have a scholarship fund that supports fellowships and travel grants and underwrites education programs. And we're now selling gear to support that. So if you go to Hoobe, HOO.be/Edge AI, we'll put that in the chat. There's a little store there. You can buy this hoodie. Is really cool. It's actually reverse camera, so it's a little disconcerting there. But yes, you can get this. You can get a coffee thing. You can get some stuff. So appreciate that. If you want to gear up for Embedded World, there's probably still time. But let's talk about what we're going to talk about today. So this is exciting. We're going to talk about aquaculture. Aquaculture, not to be confused with agriculture, but it's very similar. And we're going to talk about Edge AI and aquaculture with SoftBank and AI Zip. And yeah, interesting.
Yeah, I think we're going to start with the problem as usual, which is a problem we can all relate to. How do we acquire food? How do we harvest, what the earth has for us without compromising integrity, sustainability, and doing it in, as always, intelligent, clever ways. So I think we've really seen a bit of a trend from these real world deployments. And so really excited to have our guest today talk about, again, good problem, good solution.
Yeah. Why don't we bring them on? We'll bring on Yuan Liu and Yuko Ishiwaka from SoftBank. Yuan is president of AI Zip. Actually, let me put you in a cooler format here. So you guys get the bigger squares because you're guests. We're in the small squares.
Thank you.
But yeah, welcome to Edge AI Blueprints. And Yuko, I know it's a little bit early morning for you there, so I appreciate your indulgence.
Yes, a little bit early, just only 1 a.m.
Maybe we should do an evening version of Blueprint live streams. A better mind. Maybe,
Yeah.
And Yuan, where are you dialing in from? I think you're in California, right?
I am from the Bay Area.
Yeah. Okay. So that's easy. So we're
I'm
all
okay.
You and I are on the same page.
That's right.
Davis you're in Toronto, right? Davis, you're East Coast time.
Close, Ottawa, but yeah, a couple few hours ahead, but nothing like what Yuko has to go through. So
But we're gonna have a big audience today. Probably getting a lot of questions, and so we're really excited about digging into this. And so, what was kind of my question for you before we dig into the presentation and stuff is like, what was this origin of this project? Like, how did AI Zip and SoftBank sort of get together on this and attack this problem? What's the backstory?
Will you or I should?
Oh, I think Yuko-san, you should start. The problem comes
Okay.
from you guys, right?
Actually, the software has started at agriculture produce.
Hmm.
And because Japan has a big problem to produce fish. So a guy who is a fisherman, he asked us to solve the problem to SoftBank. So we bought the 3 fish cages in Japan, and we developed some AI solution. But unfortunately, we need cloud services. We need a GPU. So we asked to the AI chip to embed it to the HAI.
Yes, indeed. So the problem itself is, we will see Yuko-san's very beautiful slides that talk about the problems. From AI Zip side, I think the value we provide is exactly as Peter said at the beginning, is provide a solution on edge, on phone.
Mm-hmm. And is this unique? Is this the first time that you know of that kind of AI vision and edge AI has been used in aquaculture specifically? I mean, how is this I think there's been fish farming and that sort of aquaculture has been around for a little while, but I suspect this is kind of a new twist.
Yes. Actually, just only this year, we succeeded to do embedded to the HAI.
Wow, fantastic.
But we already have the booth of the CES.
Oh, right. Yes, that's right.
Nice, right.
Yeah, I think I saw a post on it, and so that I think that was one of the things that piqued our interest. Was like, wow, this is a really unique situation, because probably the challenge, and you'll get into this with aquaculture, is efficiency. I mean, we were talking about last week in Austin. We said efficiency is the new currency. That's the new metric for success, especially with edge AI, is the doing more with less cost, less power. And I suspect in aquaculture, being efficient with resources is critical for the success of the business, right? So,
that's true. Yeah, I think so.
Yeah, sure, of course. Fantastic. Okay, and we're starting to get our first question in. So why don't we should, well, actually, let me throw the question up, and then maybe we can help this person clarify. So Shubham asked, can you be a little bit clear about the problem and Japan example, which I think you're going to get into.
Actually, I think it's better to start my presentation.
Maybe we should just start it, and then
let's do that. Yeah,
he'll get the answer, he or she.
It's
cool.
still not clear. We can always we have an hour.
Yeah,
here, so,
that's true. So why don't we'll bring this up, and then what we're going to do is if you want to get into it, and then we will
seconds right.
Davis and I will sort of fade out, and although we'll be close, and then as questions come in, we may jump in and throw a few questions in here from the audience. And we really encourage the audience. This is an opportunity, as you see things, ask questions, learn a little bit, learn something new today, and learn about this solution. So does that sound like a good start? Davis, any final words of support and wisdom?
Oh, let's have some fun. This is a great opportunity to learn new things and go deeper. So I think let's get to the chase.
All right, let's do it. Yuko, it's all yours.
Okay, thank you very much. And
so I moved to the second slide. Do you want me to go back? Or... Okay, sure. Let me go back.
Okay, so today I would like to talk about the approaches to solving the challenge in the fishery industry. And that one is the solution was we got the awards and the innovation award of CES of this year. And I'm Yuko, and Yuran is came from AIG. Okay, could you show the next slide? Sorry. Oh, it's so slow. Yes, my name is Yuko Shiroka, and I came from SoftBank. Actually, I was in the academic side in Japan. I was an associate professor of Hokkaido University. And then I moved to the SoftBank, and I did something different research works. For example, neuroscience. I'm still doing the neuroscience, but something multi-agent system. And also these 3 years I'm doing for aquaculture project. And I got the national licensed marine divers to do this project. Could you go? And we made a video, so please watch the video at first. Could you go to the next slide?
SoftBank has built its own fish cages in order to conduct research and development into making aquaculture smarter with technology. Currently, we are trying to help fish farmers with AI, not only to make their work, often dependent on intuition, more efficient, but also to solve their problems. First, it is necessary to understand the internal conditions of the fish cage. At SoftBank, multiple cameras are installed underwater to observe the fish in the fish cages. It has become clear that there are differences in the behavior of fish depending on the depth and the season. In order to obtain information about the inside of the fish tanks that cannot be captured by cameras, employees who have obtained diving licenses dive into the fish cages themselves to take photographs and collect environmental data. The various experimental devices used in experiments are custom made as necessary by employees themselves through repeated trial and error. In the past, we only measured body weight, but we have succeeded in developing a body measurement device that simultaneously measures 4 data points: body weight, body length, body height, and body width that we now measure regularly. We have set up an experimental base near the fish cage where we hold briefings, prepare for experiments, and repair experimental equipment. The various information obtained from the fish cage experiments is used in a 3D CG simulation. We take the recorded video and apply it to the simulation. The data from the CG simulation is used as training data for machine learning. It is also possible to simulate changes in ocean environmental data due to seasons and weather. For example, the simulation can adapt to farms with varied cage shapes. By simulating the behavior of fish, before introducing a new kind of cage, it is possible to run simulations to optimize the timing and amount of feeding. When using our AI to count fish in actual footage, it was able to produce a result similar to humans in 1/60th of the time. We are working to solve many problems faced by fish farmers to help stabilize their business. SoftBank will continue to work towards sustainable societal adoption of these technologies.
Okay, please go next. Yeah, I will explain in the detail at later of these videos. So what is happening in the world today? Please, sorry.
I understand what you're trying to do.
Yeah. Sorry, I couldn't use my PC. Yeah. So we have so many problems in the world. For example, the terrorism or inflation, and also human broke the environment, please. And these ones threaten the food safety, please. So now, trend in the global marine product production is something like that, and fishing is stable, and the aquaculture is growing up, please. But unfortunately, the trend in Japan food self-sufficiency rate is quite low. Now it has only 38%, and importing food is very increasing now, please. And also the amount of catch is on half of its peak, and please. Also, the number of people employed in the fishing industry has been consistently decreasing. It's it is a big problem of Japan. And the role of SoftBank play in the fishing industry is we want to expand the demand and the supply of aquatic products. So today I'm talking about supply bank, and that one is we are trying to create the smart aquaculture project. Please. So why is aquaculture growing around the world? And that one is sustainable. It's okay. Sustainable production. And please go ahead. Yeah. It looks like promising in the industry, but they have some issues. So we try to break free from the completely manual approach with data-driven management. So the current problem is production efficiency and the unstable management. And the current fisherman needs intuition, experiments, and bravery. So in the future, we drive to do the optimize feeding. So we want to stop overfeeding, and to do this one, and we need number of the fish in the cage, and the size and the weight of the fish, and also feeding control. Also, if we can estimate and the control of the catch, it is very helpful for economic of the fisheries. Please. So we have the main task and the risk and the cost of aquaculture. So we need a feeding optimization, and that one is understanding fish conditions and overfeeding. And now we need a new feeding machine, and also work efficient. And they have the every day some fish is dead. But if the fish should remain in the fish cage, it's the disease is increasing. So some they have the sick, and once the one fish is sick, and the sick is spread out of the rest of the fish, so they have to remove the bodies and also cleaning the cages, and also feeding too. So and estimate and control catch, they need the size and the weight, because that one is based on the price, and also way for feeding, the possibility of growth, because they want to sometimes they change their food, but they don't know that one is how effective it is not. And also they want to reduce the death rate. Could you? And also the risk and the main cost of fish farming is based on the food. The cost is 60 to 70%, and they are doing the overfeeding, and that is why we need the feeding optimization. Please. So what we are doing now, and here is the softband fish cages. And could you next slide? And these three softband fish cages, and we bought 3 of them. And we are farming the Red Sea breams, and the per cage we have about 6,000 fish. Please. And there is softband members, and some of them have the National Marine Divers license, and also some of them and boat drivers. And I have the both license. I can drive the boat, and also I can dive into the cage. Okay, go. Please go. And here is a preparation for experiments on the cage, and they PV pipe, and also they are trying to synchronize of the camera. Please. And here is the example of the data set. Actually, we try to getting the data from the underwater. So one is from the camera, multi-camera, and we set the camera per meter, and the fish cage is the depth is 9 meters. So we use at least 8 or 9 per cage, and to get the full environment of the full situation of the fish cage. But because of the because of the FOV and the underwater, and we cannot see all the situation in the cage. So I decided to dive into the cage, and also I observed the fish behaviors and collect the data. Okay, please. And also we want to estimate the size and the weight. So we get the data of the fish, and that one the size estimation, the size measurement, we made this materials by ourselves, because we have to measure very quickly, otherwise the fish will be damaged. So we want to do something measured simultaneously. So we made it. Yes, please. So observing the 1 year of the fish cage, and we found something interesting behavior of the fish. So their behavior is different depends on the depth, and also they change their behavior before feeding and after feeding. So maybe we can detect and that a fish has hungry or not. Okay, please. But it would be the deep learning. It would be very helpful. But the problem is how we can get the ground truth data set. So our approach is to create computer graphics. So the left top is the actual fish cage, and the right one is the computer graphics fish cage. And also we create also camera, and then once we succeeded to create some object, and we can change the size of the object or shape or anything, and we can do on the computer graphics. Please. So also we simulate the water condition. So we normally, as you know, the right and the water is the red is disappeared first, and the next green, and the blue is the last one to disappear. But if the water condition is horrible, something moody, and then the disappear color is the changes. The first is red, but the second is blue. So sometimes we can see only green color underwater. So we need to simulate that part. So we create the simulate of the environment, and then after we create the environment, and then we put in the fishes. So left bottom shows our simulation result, and also the real one. The left-hand side is the real recorded data, and the right-hand side is our simulated data. So it's quite similar to the real one. And once we succeeded that one, we can add the fish numbers, something like the same as actual fish cage. Please. So once we got the simulation, and it's easy to get the ground truth data because we know everything. So that one, for example, 3D bounding boxes and 2D bounding boxes, and also segmentation, and we can get all the data. Please. Then we try to do fish counting. So we succeeded to do more than 96% of the accuracy, because even the human counting is not accurate because they use their eyes, they use the counting machine. So sometimes they do the double count, and sometimes it's missed the count. So no one knows the exact number, but it's quite accurate. Please. So what we are working with AirJip. This video shows the side of the actual fish cage. That one is, you can see it's a lot of holes, and it is very unstable, and sometimes a very strong wind is coming. So we have to very gets the balance of our body. And also there are no power supply and also no Wi-Fi connection. So please go next.
Do I move forward?
Yeah. And also we have to protect all equipment from the seawater. So everything is so easy to broke. Please. And I already told us that there's no Wi-Fi connection underwater and no power supply. That is why we need edge AI. Yes, please. So we made a Watatumi, and that one like the AI-powered submerged fish farms.
Software suite. In recent
Please
years,
see the video again.
the aquaculture industry has expanded, but most fish farms remain small scale and cannot afford expensive, large-scale equipment. Essential tasks such as fish counting, size estimation, disease detection, and transporting are often done manually using traditional methods. More complex tasks performed by professional crews or neglected. Therefore, there is a AI-powered fish farm monitoring to lower costs and improve efficiency for small-scale aquaculture producers worldwide. Lightweight and low-cost AI solutions are crucial for tracking fish growth, counting fish during cage transfers, determining quantities for sales or transport, and optimizing feeding to minimize fish meal waste. From a management perspective, these solutions promote safer and more sustainable aquaculture practices for both people and the ocean. Our solution uses AI models to automatically count fish, estimate their size, and detect fish net damage. These models can be deployed directly on edge devices near underwater cameras. To overcome the challenges of collecting underwater video data, we utilized 3D computer graphics technology to generate synthetic and photorealistic fish farm data for training our neural networks. Leveraging AIZip's innovative, efficient neural network architectures and TinyML platform, our models are embedded in edge devices while achieving superior accuracy. This solution has a potential to revolutionize the aquaculture industry.
Cool. Yeah, I thought we could
Wow.
pause for a second to take a few questions. We got a few questions piling up here.
Okay.
Maybe we can jump into that. Davis, there's a little bit of background noise for you, just FYI.
Okay, I'll try to mimic your minute.
I think the so one of the ones that came up here was so we'll just start from the top. So in terms of the camera deployment, imaging deployment, the question was, do you have cameras working at night as well? I mean, what are you doing about low light situations? Have you considered using other technologies other than vision, like radar, LiDAR, things like that?
Actually, we don't use the camera in the night. And we already tried to do radar, but it doesn't work well because the water is very protected from the radar.
Right. Okay. Cool. Similar one from Alexander. A second follow-on question. So I guess this is just this is a question we always get with Edge AI deployments. What kind of compute is happening at the point of collecting the data versus are you using any kind of heavy computational gateways on the back end or any cloud resources, or is this all happening like in the camera itself, or how does that?
Actually, the camera doesn't have any power source, so we use the battery and we use just the micro SD card to record the data. So just only 1 hour we can get the data of the camera.
I see. So in terms of running the AI workloads to count and size estimation, are those workloads running like on land, using the cloud, or using the phone?
Actually, now it's just only running on the phone.
On the phone,
running
okay.
On the iPhone 14.
Cool. Excellent. Go ahead.
I just want to add one thing is beside the phone, we do have deep underwater this protection over the phone, so the phone is not exposed to the water.
Right, the phone's not exposed to the water, right? But you're using it as sort of the AI platform for running the models.
Exactly.
Right. Yeah. Here's another question.
Is that a limitation of the compression? Oh, sorry. No, I was just very, very quickly. Is that a limitation of the compression available for these models that you need a smartphone, a CPU, or accelerator, or do you think you could port them to even lower, intensity cost platforms like Edge SoC?
So Yuko-san, you want me to answer that?
Yes.
So as a matter of fact, when we started, we discussed this instead of reduce the resolution, we probably want to increase. If you look at some of the images here, Yuko-san mentioned that in some of the cases in March and April, the water is very muddy. So we like to increase the resolution. But fortunately, according to our trial, based on simulator that Yuko-san has as some real life images, it seems like the accuracy is pretty good with a given phone. But Davis, the question you asked is really good. As a matter of fact, we believe at the moment that we can reduce we don't need 4K or 2K images to do a good counting. So the biggest problem we have is the field of view for the phones. Yes.
Interesting.
Okay.
Let me throw one more question up there before we jump back in. Question was, and I think I saw a slide on this, but how many different types of fish? This is where I thought it was also interesting you're using sort of simulated data to do your training, which is a whole other discussion. But this works with, you're training it on multiple types of fish. I saw 3 types of fish in here.
Yes, actually, there looks like red sea bream, there's salmon, and it is succeeded. But maybe not like eels.
Eels. Oh,
Maybe
it
doesn't work. We need.
I don't
We
like
need
eels.
a training data set.
So
But the fish is okay because I visited some aquarium and I used this application to over the.
Oh, okay.
And it works.
And so typically, I suspect in these aquaculture, in these nets, in these cages, they're all the same type of fish.
Yes, in the net, yes. But
Yes.
the fish shape is very similar.
Right.
Yeah.
Interesting. Okay. Cool. Why don't we let you jump back into your presentation, and then we're collecting more questions on the back end, and then we'll take it from there. How's that sound? So
this slide is for Yuan. So please explain your technical details.
Yeah. As a matter of fact, so as Yuko-san mentioned early on, the key factor this possible is we have a simulator, which can generate a lot of data for us. So we typical thing we need to deal with is what kind of network we need to select, right? So we very quickly looking at the real life images, saying that object detection doesn't work. There's just the density of the fish is just so large. So we are seeing the images with hundreds of thousands of fishes. So instead of using the traditional object detection methods, we select a different method. It's called density-based crowd counting. And we look at the state-of-art methods and come up our own architecture, be able to run on the edge. So our goal here is with resolution from the phone, normal images, even with muddy water. So should be able to run supporting enough of the frame rate that the phone can count in the reasonable time using the NPU possibly or DSP on the phone. And so this is some parameters, problems that we are dealing with, and the data supporting what we have done. So as I mentioned in the previous slides, the total number of fishes can be over 500. As a matter of fact, in the CES, you could have a large screen, have a lot of fishes, and we have a live demo with the phone in front of the screen to be able to count over 500 fishes that I have seen. And fish in the distance on the water is very difficult to see. but we still need to somehow count it. So that's why, in having enough data from simulator is very important, right? Even the fish is very difficult to see the eyes, but we still can see a sheet and a shape of the fish is important. As I mentioned, the biggest problem we have to deal with is muddy water. The water itself is even green in the spring. So this domain shift from normal water is very difficult. Okay, so based on all this information that we have obtained from SoftBank, we made some decisions on the training data. So we take 22% of public data set, mainly from Fish 5K, which is available. And then 65% of the data is coming from the synthesized data sets generated by SoftBank Simulator. We also take 5% from Coco dataset by just running the approach that Yuku-san already have, and to extract those useful images, and 5% from the public fish video frames, and use that to conform training data and train the model. Okay. So as I mentioned, the model itself is density-based crowd counting model. When we started, we are not really sure this will work, but fortunately, it works very well when you have a large number of fishes. So we have built up a test set with really human counting for the clean water images as well as the muddy water images. I still remember there's one day, so AIZ folks sit together and count every fishes in every images we used. So the accuracy is for clear water is quite good, 96%. In muddy water, we lost 10% of the accuracy. So Yuko-san, I think I probably go back to you.
Okay. So what we want to do next, and we would like to create the AI modeling to detect the fish growth. That one need to reduce costs and also increase the profits. So please. And we would like to rebrand the fisheries industry from harsh work condition to attractive working condition. Actually, from 3D to 3H. Yeah. Yes, please. Also, we'd like to redefine the industry with the power of the technology and working towards a sustainable society. Actually, in the fish farm, the fish food content is the fish. So we have to change the food of the fish from the fish to something vegetable or something different. But to change the food, but normally the fish doesn't want to eat the vegetable food. So they want to track the growth of the fish if they change the food. So we need something, the monitoring system of the fish. Please. And actually regards the awards of the innovation of the CES 2025, and we got the booth, and there are so many people is coming to our booth. It is very appreciated.
Indeed.
Yeah. Okay. And that one is the last slide. Yeah. Thank you for the listening.
Thank you.
Wow. So there's a tremendous amount of questions coming in from the audience. I don't know, Pete, if you remember where we left off in the previous talk track.
Yeah, we have a lot of good ones in here. I think one of the things that was a question, I had a question too about the simulated training. You mentioned 65% was simulated data, and someone had a question around simulation tools. We're using generative AI for the simulated fish. How did you go about? What was your tool chain for simulation data?
Actually, we use a Unity.
Okay.
Oh, Unity. Okay,
Unity.
so the gaming engine kind of
More
thing.
computer graphics,
engine,
yeah.
And everything is scratch. We don't use any other tools, just Unity, and we create some models, and we create the animations by ourselves.
Okay, good.
Everything is the original.
Right.
Yeah, one comment I noticed from yourself, Jan, on AIZip's behalf was, it sounds like no matter how good AI models get, we'll always need people because we'll still need people to label the fish or to get the ground truth or to get, some kind of,
Yeah.
cold start. So I just wanted to highlight that. So it's always the two working together. There, you can't replace one or the other.
Yeah.
That's very true. So I think if you look at 4 years ago when we started, everything is without the good data, we cannot really train anything.
Right.
I think the last 4 years is Unity is one thing that you could send. The first time I saw it, I was shocked, right? So so SoftBank team was able to come up this beautiful simulator, not only simulate fish as well as simulate water condition. And then Gen AI comes, right? So at least from our experience, it's not 100%. It will give you 30% in some cases and 40% in other cases. But in order to be able to do well on real life, we does need a human involvement for sure.
Right.
So for example, the test data I mentioned is done by human. We cannot trust using simulation data for testing purposes. Have to be real life.
Right.
Got it.
A couple other good questions here. I'll just kind of bounce around. Abhishek asked about metrics. What are your KPIs to validate performance of the model? Like, what were you looking for in terms of accuracy and other metrics?
So let me answer from AIZip side.
Yeah.
For sure, this KPI is coming from SoftBank, right? From our standpoint of view, our current model have done live testing in real life. You could take the camera into the water and test it. So in the normal cases, it works quite well. So we have seen somewhere between 92% to 98% of accuracy in real life testing. So we have a reasonable confidence that it will work. So the only thing here is how do we deal with a very scenario? We probably need 1 year of testing of this to validate, at least from our definition of the robustness, before we claim this is really top quality or not, right? And also we will expect there will be feedback. That's a very typical from our experience of doing production. Yuko-san will test it and have some images doesn't work well. Then we need to come back and retrain the model. That's what will be expected. The good news that we had is we actually have tested this model using not only in-domain data from Yuko-san, we also tested with out-domain images from like a wide world. It's pretty reasonable.
Okay, cool. Here's another one, not really Edge AI related, more of just, salt. I know there's like IP68, IP72. So what is the designation for salt water tolerant microelectronics? Is there an IP designation for that, or maybe that's more of a question for Dr. Ishiwaka?
Yeah. So actually, what's the requirements for salt water? Salt water is the enemy of all electricity.
Right.
That's a good way to put it.
Requirements are don't get it wet. I think that's the requirement.
Yeah.
Right. Yes.
And actually, if it is not salt water, maybe if after dry, sometimes microelectronics is survive. But if with the salt water, once they got the salt water, it's horrible. No electricity, it survives. So we need some waterproof, and we always use something housing, water protect from the housing. Yeah, but for once we try to put in the water with some how can I say electricity, it's not without any cover. So we use some soft. How can I say, and we something very soft plastic part of the to proof waterproof of the phones, and then we put in the electricity in the soft one, and it will survive until 5 meters. but we put in the 9 meter and it was broke.
Oh, I see.
Yeah.
Pressure.
So water pressure is also our enemy.
Right.
Yes.
Right. Interesting. Yeah, I can see that. Good. Let's see. We had a couple other good ones here. And Davis, feel free to chime in if you see one that catches your eye. Let's see.
Well, I think they're talking about the size of the models, and they're so Shumamid also asked a question, kind of similar to what I asked earlier about the compression. And is a smartphone the right edge inference engine, or is it the limitation? So I think there were some more specific questions that maybe AI Zip can comment on the size, and that's deployed on mobile and maybe future deployments as well.
Right. Yeah.
Sure. As a matter of fact, it is actually very much involved Yukusen as well, because it takes us about 2 weeks to decide which machine to run on. So we pick mobile phone simply because it's not because we want to use it permanently. It's more like the conveniency.
Right.
And it does have a little bit waterproof. At the same time, so iPhone 14 already have NPU inside, right? Computation is good enough. And the connection from the camera all the way to the NPU is given. And as a matter of fact, I think following the previous question that Yuko-san answered, we do want to have unique, separate devices, self-built, because of all these issues, water pressure, salty water, and if you want to have something, putting over a few days. So there will be, I learned from Yuko-san that there will be, vegetation climb over your phone, over your cameras. So all this stuff have to be somehow well thought as well as well made. So going back to the so the phone, in my opinion, right? Just in my opinion, I think we can probably have a less powerful chip to be able to run even easier iPhone 14 if we go to production and move to this more optimization.
Right.
Excellent.
Yeah, I suspect you probably lower your price of your device, increase the ruggedness of it, and maybe also extend the battery life as well. Probably.
Yep. You bet.
Which is key. I mean, you don't want to have to recharge these things. Yeah, interesting. Let's see. I had a question here that came in here from Sam Fuller. Do you aggregate video from multiple cameras into a single processor, or do you do the computation distributed per camera, or how does that work? Like, so topologically speaking, how does that work?
So Yuko-san, I probably can only answer half of them because of the video come from Yuko-san. So I really, from my standpoint of view, I don't really care how many cameras. We will, from AI Zip side, just every single images we need to count, right? So Yuko-san can use it differently. Yeah, go ahead, Yuko-san.
Yeah, actually, for our side, the reason why we use multi cameras, we want to observe the full inside of the fish cage. So we try to synchronize first in the air by using our voice, and we try to do stitch of all images. But we are still working on that part. It is not easy, and we cannot adapt to the usual tools because all fish seems similar. So we cannot choose which one is the right one. So two cameras might have the same fish, but human cannot detect which one is the same fish.
Right.
Yeah.
Interesting.
So that part will also we have to use the computer graphics.
I see.
Right.
Yeah.
Here's an interesting twist on that. You had mentioned that you're using the cameras to also detect damage to nets and damage to the cages. What about, can you detect anomalies in the fish themselves and look for diseased fish? Has that been tried yet?
Anomalies.
Or is that in the pipeline?
Actually, we are observing the fish behaviors. And also the disease fish behavior is so different from the normal behaviors. So I suppose it's we are working on, but I think it's possible.
Cool.
Yeah.
And here's a related question: does it work for shrimp?
Yeah. it doesn't work for shrimp, but maybe we are trying. Yeah, some
we'll
fish fun shrimp farmers asking to do that.
Okay, good. Yeah, I'm sure. Yeah, shrimp TBD, I guess.
Yeah, we have to create objects.
Yeah, you know.
Some seafood fans in the audience. Yeah, good.
That's
good to
right.
hear.
Yeah, everyone's kind of getting there, figuring out their favorite seafood here.
Lobsters.
Lobster. I'm glad it's not working for eels because eels is my least favorite. I'm okay with that issue. Couple other things. What do you see here, Davis? There's so many questions coming in.
I mean, there's a few more. I like the ones that are kind of non-technical, like what we're discussing here. But there was one that caught my attention from Alexander. Or actually two people kind of asking similar question. What does the development flow look like for the AI? You're training in common framework, PyTorch, TensorFlow, and then are you converting to TF Lite for the phone?
Right.
Are you using Onyx?
What is
Are
the
you using
whole tool chain
Qualcomm
look
AI
like?
Hub? Yeah, let's get a peek
What's
at
the
that
stack?
too.
So you could send. Shall I answer that? This probably
Yes, please.
I can share some of our experiences. So 4 years ago, TF and TF Lite is the primary thing. TensorFlow is the primary thing. But when we started, we realized that the PhDs from my company, they refused to use the TF Lite or TF TensorFlow. So unfortunately, we actually started with PyTorch. Fortunately to us, that's become a trend that people start using PyTorch a lot, right? Last few years ago. And then the problem we had is how can you get PyTorch to the deployment? I think TinyML and Edge AI Foundation have a lot of people contribute over that beside us. So we are just one of them. So for us, from first we start from PyTorch to C, and then from PyTorch to TF Lite, and then to ONX are all valid approaches. The only thing that we realize which is we have been sharing with our partners as well as customers, is that when you do this compiler SDK, so please leave the quantization to these AI companies, because quantization is a critical element. And if you do that in your compiler, and we don't have a way to play with it, we cannot, do mixed precision. That's oftentimes give us hurdle to not be able to do. So, Davis, this is the one thing that I shared with Ali before as well, is that give us the option that we can quantize and then give TF Lite or ONX to you. You take that to compile. So I think I have been sharing this with a lot of people.
Yeah. And one technical follow-up on that, this has become my favorite question nowadays. Have you heard of ExecuTorch? This new initiative from PyTorch? Yeah, okay.
Yeah, as a matter of fact, we are working quite closely with Meta team, including Yuko-san. So if ExecuTorch can directly compile from PyTorch to executable, that's actually solve a lot of problem that we have. Yeah, we very closely watching and trying. Yeah,
cool.
Agreed.
I had a couple of questions come in, Davis, on like the kind of the training, training aspects. One was going back to you're mentioning about muddy water and things like that. Like, what are you thinking about in terms of model training to mitigate, the risk of that challenge and adding noise into the training data? Like, this is one suggestion from Abhishek, but.
So I think you probably should talk about how muddy the things is.
Yes. And actually, we try to use sim to real to cross to the real world. So I think it's very useful.
Yeah. So I think the key solution.
And what kind of noise? That's the problem. What kind of noise we should add?
So I just want to mention this Unity-based simulator is the key. Without that, we don't have those enough muddy data to train. So having the simulator become critical for these muddy situations.
Yes. There's a question here around Unity. Actually, it's more for the application development for the phone. Did you use Unity? I mean, what's the workflow on developing the application that you used on the phone?
Actually, Unity is just for the simulation. So yeah. So how about I think the answer from the Yuan.
Yeah. So Unity is not on the phone. We essentially SoftBank, when we started, we actually enjoy the fruit from SoftBank. They already have a Unity based simulator. They can tweak it. We become user of the simulator and create the data for us. So there's everything is running on GPU on servers. So the phone side is get the model and run the model on the phone only.
Yes, just
What
using
about
the
the
Unity for creating the ground truth data.
Right.
Yeah.
What about Cosmos from NVIDIA and some of these physical AI world models? Maybe it overlaps with the Unity. It already covers that. Do you guys see validity to what they're doing? Of course, they've done computer graphics for decades. Now they're doing this physical AI world modeling simulation models as well. I'm curious if that is of interest.
So Yuko-san, how about you answer first, then I follow.
Yeah. Actually, I don't catch up his question. So maybe I think the Unity has a very good engine, and we can use something like the computer graphics. Actually, in the world of the computer graphics, they have two options. One is Unity, and the second one is Real Engine. So, and Unity has a lot of assets. And for example, the ocean environment simulation, the Unity has one. And so it's so easy to implement to that kind of things.
Cool.
Yeah, regarding to world model, so this is definitely one direction. I think this is a buzzword for the industry for, I think, since last year. So we are watching it. So we haven't done much on that from given our BD schedule. So we definitely watch, and for us, it's not direction that AIZip is taking. Instead, we'll be their users if the model is ready, right? So, So I don't have enough of experience to see more.
That makes sense. Thank you.
Cool. Well, we're kind of running up on our time here, but but we'll continue the conversation offline with Q&A and things like that. But really appreciate your time. Again, Dr. Ishiwaka joining us from early in the morning in Japan. Thank you so much. And Yuan Lu from AIZip in the more reasonable time zone of California. But it's great having you here. I think we learned a lot. I think the audience learned a lot. And, this is an interesting pattern that I'm sure could be applied to lots of different commercial problems out there. And so great to see this kind of pioneering work happening. So thank you again.
Yeah. Thank you for being here.
Thank you all.
Thanks to the audience as well. Thanks for the engagement. I think that was a fantastic engagement. Yeah.
Thank you.
Great. All right. See you around, everybody.
See you next time.
Bye.